most people, a trip to the supermarkets is just a matter of making the list, finding the keys, piling all the kids and the dog into the car, and making it back home before the ice cream melts. The last thing on a shopper's mind, however, is the painstaking effort that's taken to ensure they take home a quality product.
Ugh! And it's no small job to make that happen. As you can see, a mega market such as this is a far cry from the mom-and-pop stores of days gone by. Today, your grocer must maintain state-of-the-art refrigeration facility, not only for comfort cooling, but for an assortment of freezers, coolers, dispensers, you name it. If it chills, cools, or freezes, it'll be found at today's modern grocery. To begin with, these produce cases, considered to be medium temp, must maintain critical temperatures, 35 to 38 degrees to ensure freshness. Don't want to freeze the leaves off the lettuce.
35 to 38 degrees may seem like a lot of room for error. However, 1 or 2 degrees difference can be very critical. For example, the temperature in this area, although in the same case, may vary a degree or two from that area depending on the needs of the product.
These are all medium temp cases, but some products got to be cool, not cold.
And for that birthday or special occasion, what have you, these flowers not only have to be kept in a cool environment, but one that's highly humid as well.
Fresh fish is not only kept in refrigerated ambient cases, but often on a bed of ice as well.
All of these exposed or open cases use a curtain of air concept to separate the product from the ambient air.
Some freezer cases such as these actually use 3 curtains of air to separate the product from the outside ambient air. Pretty sophisticated, huh? These cases are considered to be low temp units. They're kept at a variety of temperatures depending on their size and whether they're horizontal or vertical.
These closed-door cases differ from the open ones only in that they run a little warmer. About -5 degrees ought to be okay. Except for ice cream. Ice cream cases need to be kept at about -12 degrees for a closed-door case, or -24 for an open case. Either way, they still use the same curtain of air concept.
Dairy, like produce, is kept at between 36 and 38 degrees.
There's one product states clearly on the label that beer has to be served at 37 degrees. And there's another line that states specifically in the vendor's contract the product needs to be refrigerated from the factory all the way to the consumer. That's a mighty tall order, I think, huh?
A lot of deli meats and cheeses are smoked and considered ready-to-use product. They're stored at about 32 degrees. Fresher, ready-to-cook meats are stored at slightly higher temperatures. Remember, spoilage is critical, but appearance is important too.
With poultry, even a variance of a couple of degrees can make a product look unfavorable, even when it's not.
How convenient is this? This baby not only makes the ice, it bags the ice, and it stacks the ice. Heck, around here, there's a guy that'll even tote the ice out to your truck and load it in your cooler for you. This is one of the few machines that operates completely independent from the rest of the equipment that we've actually been discussing. These flue stacks carry the coolant from the evaporators to the racks of compressors that are located up on the roof.
Up here, a refrigerant man
Or woman
is in his very own world. Look at all of this. The compressors that serve all those evaps downstairs are grouped together in racks, housed in shacks here on the roof. Here you can see the line set coming out of the roof, and it wends its way towards the rack shack. It's going to get mighty noisy as we get closer to here.
Bob, they can't hear you. Use the voiceover.
Oh, okay. The compressors are grouped together in these rack shacks for convenience, safety, economy, protection from the weather, and in general, a more technician-friendly environment. And speaking of friendly, these compressors have all been retrofitted to use the more enviro-friendly HFC R507 coolant instead of the ozone-depleting CFC R502. All of these units are 460-volt, three-phase reciprocating compressors. In most cases, one compressor will service several evaporators at different temps. Is that complicated? Not at all. Take a look at these evaporator pressure regulators, or EPRs, back on the outside. Different temps in the evaporators can be regulated by the EPRs, which control the pressure in each individual evaporator, resulting in a specific temperature for a specific area. Refrigerant flow at the evaporator inlet is still controlled by a TXV, as in most default applications, and in this case a lot of the factory set valves have been replaced with adjustable units for more precision control and less temperature variation. Let's go back to the drawing board for a second and get a more visual look at the refrigerant cycle that's represented here. As you can see, different temps are maintained at each evaporator by different pressures, maintained by a separate EPR for each area of the case. Severely low temps must include a check valve to ensure that no refrigerant backs up into the lower pressure evap from a higher pressure evap. And back at the shack, a central processor controls everything. Okay, this CPU doesn't do everything, but it does control things such as the defrost cycle and monitors for faults indicated by extreme pressure changes. It does afford the technician a quick overview of the status of every operational cooling facility connected to it, and that makes life a little easier, I'd say.
For example, take a look at how this controller manages the defrost cycle. Defrost is critical. You have to defrost the unit, but you want to do it in such a fashion as to not jeopardize the freshness of the product. All of these defrost cycles are scheduled by the microprocessor and timed for a predetermined length, but the sensors will override and terminate the time cycle if the evaporator defrosts sooner. The schedules and timed lengths are displayed to avoid unnecessary alarm by an overnight employee who might be looking out for temperature changes in the display case.
Yep, this controller is like the nerve center for the whole cooling operation.
Except, of course, for those ice machines we talked about earlier. They're off in their own little world.
All the other refrigeration condensing units are centralized here in the rack shacks. They're not much different from any other condensing coil configuration, except it's a little more convenient having them all grouped here together. For energy saving purposes, the fans only run when necessary, ramping up and down as required by the condenser pressures. This is controlled by a separate control called the VSD, or Variable Speed Drive. The VSD up here may seem high-tech, but it's just a sophisticated form of control. It's not unlike the controls used to vary fan speeds for similar or other purposes as needed.
Another energy-saving device is the recycling of hot water, heated by the condenser coils and stored in these hot water tanks for use elsewhere. Now that's smart.
As you can imagine, all of these evaporators require a lot of refrigerant. This is one of the larger liquid refrigerant receivers used in the commercial refrigeration industry. It has to maintain a level of refrigerant sufficient enough to supply all of these evaporators and at the same time have enough room left in it to be able to pump the system down in case of maintenance or repairs.
And let's not forget comfort cooling in the middle of all of this refrigeration. The comfort cooling here is not much different than it is at your home or office. Just a little bit bigger and definitely noisier.
Remember, indoor ambient temperatures and humidity must be strictly controlled or we'll never get those evaporators down there to cool properly.
The temperature and humidity sensors are located inside the store near the doors. They constantly send the information they pick up back to the main controller.